Alright guys, so this set of video notes is going to go over the basics of wind and how wind is created, and then it'll also talk about heat in the atmosphere, as well as wind patterns and different ways that heat can transfer. So to get us started, we have to talk about the actual definition of what weather is. We all think of weather as being like precipitation or temperature, but weather is defined as the current state of the atmosphere. So what is actually happening right now? Is it 72 degrees and cloudy outside? Because that would be weather if that was what was happening in the atmosphere at that specific point in time. So we talked about the definition of weather. So there's something, a process in weather that's called convection. And this is very important for you to know. You might hear phrases such as convection currents or anything along those lines. So you need to know that convection is the transfer of heats in liquids and gases. So convection is the main process that's going to be moving heat through our atmosphere and oceans. So like when the ocean water heats up, and the liquid then turns into a gas, that's through the process of convection. In our last unit, we talked about temperature, and we talked about how temperature is not just hot and cold, that temperature is also defined by how fast the molecules are moving. We talked about with really warm objects or really warm air, your molecules are going to be spread apart, but they're going to be moving really fast. So the higher the temperature, the higher the movement of molecules you're going to have, which makes it feel hot. Now the opposite, when it's cold, molecules huddle together and they're moving really, really slow. So the lower the temperature, the lower the movement of molecules, which is going to make it feel cold. We talked a lot about air pressure, your last set of notes, and we talked a lot about how warm air rises and cold air sinks. Now, how that works is whenever you have warm air, it expands, it rises up, and then it leaves under it an area of low pressure. So where this warm air used to be, it's now going up and leaving this empty area, and that's an area of low pressure. Cold air does the opposite. Instead of rising, cold air sinks. So it's going to leave an empty area above it where it used to be. So when you have cold air, it leaves an area of high pressure behind. Now we get to talk about wind and what exactly causes wind. So wind is defined as the uneven heating of the Earth's surface, and this happens because some areas are going to be warmer than others. So when we have areas by the equator, all of those areas are getting hit pretty directly by the sun. But in other areas, like at the poles, where it's not getting that direct sunlight, it's going to be a lot colder in those areas. So this uneven heating is causing some areas to be warmer and some areas to be cooler. So when this happens in our atmosphere, that's when wind happens. Whenever we have this uneven heating of the atmosphere. Whenever there's uneven heating, there's also issues with air pressure, so that's when our winds start moving. And something very important for you to remember is that the equator is going to be your warm areas and your poles are going to be the cool areas. This slide just covers a lot of basics about wind that you need to know. We talked about how wind is caused by an uneven heating of the atmosphere, which in turn causes differences in air pressure. We know that the higher the temperature, the lower the air pressure. So those changes in air pressure and changes in the heating is what's going to be causing wind. Now, air pressure changes because of that uneven heating of the atmosphere. And we look at two things whenever winds occur. We measure winds based on the direction that they're blowing, and then also how fast they're blowing. So if we're measuring wind, we're going to say that it's going 20 miles per hour east. So I just measured wind by giving you a direction and a speed. The tool that we use to measure wind is called an anemometer. And another basic fact you need to know about wind is the phrase wind chill. So the wind chill is just the increase in cooling that the wind causes whenever it's actually blowing. So it makes it feel colder than it actually is. This is where things get a little confusing, so try to stay with me. We have such things as local winds and global winds. Obviously, the difference between the word local and global. Local means areas nearby, and global means global, like across the globe, large areas. So local winds are going to be our winds that occur over small areas or local areas. How this works is it's called a sea breeze. And the main thing you need to remember is that the land cools and heats faster than the ocean. So the land can cool off quicker than water can, and the land can heat up quicker than water can. Now, it takes water a really long time to get warm and to get that heat, but the cool thing about it is once the water actually gets heated, it's going to hold on to that heat a lot longer than land does. And it also kind of makes you think of if you go night swimming. Obviously, the temperature is going down at nighttime, but when you get in your pool at nighttime, it feels like super warm. That's because the water is still holding the heat that it was absorbing all day long. So your water is actually staying warmer. How the sea breeze works in this situation is it happens during the daytime. And what happens is the sun heats up the land, obviously quicker than it heats up the water. So the land gets hotter faster than the water does. And that heated air we know rises. So the warm air rises. And something's got to come into that area where the warm air rises, and that's called a sea breeze. So how the process works is the warm air rises, and then it goes up over the sea and descends down once it cools. And then that cool air causes a nice little sea breeze onto the land. So if you remember when you go to the beach on really hot days, it might be super hot if you're at home, but if you're at the beach actually laying on the sand, there's always a really nice cool sea breeze. Like the wind always feels really good at the beach, and that's because that warm air is rising over top of the land during the daytime, and that cool air drops down and causes a sea breeze, which keeps it nice and cool. Now the opposite of that is a land breeze. Land breezes occur at nighttime. So this is not a daytime thing. Land breezes occur at night. So this is like the exact opposite. Now at this point, water is going to be warmer than land. Your land's lost that warm air that it had during the daytime because land doesn't hold heat that long. But your water does. So now our water is warmer. So that rising warm air that we did have over the land during the sea breeze, now that rising warm air is over the ocean because the ocean is the warmer object. So that warm air rises and it descends down into cool air over top of the land, and that cold air from the land causes a nice little breeze out to the ocean. Now, when we look at wind and we look at temperature and air pressure, there's something called a pressure gradient that you guys need to know about. So whenever land is hotter than water, so that's our sea breeze, that's during the daytime, the heat rises and then the wind from the sea replaces that warm air. When that happens, there's a pressure gradient that occurs. From sea to land, so from ocean to the sand, the wind moves from high pressure to low pressure. Now, the lower the pressure, the higher the gradient. It's an opposite relationship, all right? Wind speed also depends on the gradient. So looking at the pressure gradient is going to tell you how fast the winds are going to be blowing. If there's a high gradient, then you're going to have really strong winds. If there's a low gradient, you're going to have weak winds. It won't be that strong. And the force that provides the actual strength for those winds to blow is called the pressure gradient force. Now we talked about local winds, our sea breezes and our land breezes. But now we're going to talk about global winds, which occur over large areas, all right? So there's a couple of wind belts you need to know about. The first is the horse latitudes. These are at 30 degrees north and south of the equator, and they're areas of calm winds, okay? Something about the horse latitudes that's really cool is back in the day when people were traveling and trading and doing all that stuff, they would bring their animals, they would pack up tons of people and things on their ships, and whenever they would get to this area, 30 degrees north and south of the equator, the winds were not strong enough to move their sails and to keep their boats going, so they had to drop things that were heavy out into the ocean to lighten their load, to get them moving. And if they had carried their animals with them or their horses, this is where they would dump their horses overboard to lighten their load and to get moving again. So that's why they're referred to as the horse latitudes. You guys also need to know about the jet streams. This is about 10 kilometers up, so it's at the very top of the upper troposphere, and they blow from west to east, and it's a narrow zone of strong winds. Now, the jet streams are carrying weather. They carry actual flying jets, so the jet streams are very important to us. Another type of global wind are the trade winds, and the trade winds are easterly winds that blow from horse latitudes to the equator. We just talked about the horse latitudes were 30 degrees north and south. So these winds are going to blow from 30 degrees north and south to the equator. And since they're easterly winds, that means they blow from east to west. Another type of global winds is the doldrums. This is an area right by the equator, and there is little to no wind here. Okay, these are areas that have very little wind. You can think of them as being dull, and that'll help you remember that the doldrums are areas that don't have very much wind at all. So this picture just gives you a nice visual of all the different winds that I've talked to you about so far. If you see at the top and bottom, so by your poles at 90 degrees, those are easterlies, which means they blow from east to west. Then you have your westerlies, which blow from west to east. Your horse latitudes are labeled at the 30 degree mark. Your trade winds are from your 30 degree mark to the equator, like we talked about. And then there's little notes on the side that let you know what happens at each point as far as air pressure goes. Something really interesting that we have to talk about is the Coriolis effect. So nobody ever really wonders why our winds blow from side to side instead of up and down, but there's a reason for that, and it's called the Coriolis effect. This is defined as the way that Earth makes our winds blow in a curved manner because of rotation. So we all know that Earth rotates on its axis, and it rotates kind of side to side, obviously, not up and down. And how it's rotating is causing these winds to blow in that curved rotation. So right to left instead of up or down. In the northern hemisphere where we live, our winds blow towards the right. And then in the southern hemisphere, winds are going to deflect and go towards the left. This is the process that is responsible for the really nice, pretty rotation that occurs in the strong hurricanes that are forming in the oceans. The last thing we have to talk about is heat transfer. Heat transfer can happen in 3 different ways. One down at the very bottom we already talked about, which is convection. Remember how I told you that convection is the transfer of heat through the movement of fluids and gases. So convection we talked about was important in the atmosphere because whenever the heat from the water, when the water got heated and it evaporated, it went up into the atmosphere. And that's by convection, which is the transfer of thermal energy by the movement of a fluid. The other 2 are conduction and radiation. Conduction is the direct transfer of heat from one substance just to another substance by touching. So the two objects have to be touching. So if you look in the picture to the right, you see the guy who has protective covering or a glove on his hand and he's holding the really hot poker stick. That's heat transfer through conduction because the glove is touching the object that's being heated. Now, radiation is the direct transfer of heat by electromagnetic waves. So whenever you put your hand up to beside the fire and you feel it producing that heat, that's radiation. It's radiating off of the logs. And then the example for convection that it shows you is the actual smoke arising from the heat and heating hands above the fire. And that's all I have for you guys. Thanks.